Hello, I'm back with this next unit of trigonometry. I'm going to try to talk about special right triangles, which are a subset of hypotenuse and right triangles and Pythagorean theorem. And then with that, that's going to bridge us into the unit circle. I think this might be one long video or several shorter ones. I haven't quite decided yet, but I know this image looks daunting, but it really isn't that hard once you get used to it. So let's get started. First thing I'd like to do is review how to do radian to degree conversion, just to get things moving. I'm trying to actually, okay. So here we have a question. How do we turn this, oops, bypassed. How do we turn that measurement that we saw in the 4 pi over 3 into degree mode? And if you remember, we went on over that. That requires that you do the conversion of 4 pi over 3 into degrees. And that's really easy to do. As you remember, what I told you to do was every time I see the pi symbol, I would replace that with 180. And that'll turn it into 4 times 180 divided by 3. And I could divide 4 by 3, but there would be a point to that. They're mutually prime, which means that they don't reduce. But 180 divided by 3 does. That's 4 times 60. And that would give me 240 degrees. So my correct answer would be here. And this file gives me the ability to pull out the result of that. That's C. So I hope that makes sense when you do this one. Let's go on to the one that we saw before. It's a little slow in turning pages for some reason. I don't know why it does that. And then sometimes I think it's not going to do it, then it does it. All right, 2.5 radians. 2.5 radians, and I want to turn that into degrees. Okay, so when I want to take 2.5 radians into degrees, I'm going to have to multiply that by 180 over pi. That'll be my conversion factor to do that. So I'm going to break out my calculator, and I'm going to do exactly how I see it in front here. So I'm going to do 180 times 2.5. And then I'm going to divide this by pi. And pi actually is a symbol in the calculator. It's up here. And your calculator will, in fact, have it, but you have to look around for it. And then when I divide out, I get 143.2. That's going to give me the answer being B. So B is the correct answer for this one. And again, not really hard, but there is a difference here with the ones you've normally seen before, which is that normally 2.5 radians wouldn't appear like that, and you would be thrown off because there's no pi into it. But the way to think about that is that 2.5 has got pi baked into it, right? It's got some value that was multiplied by pi. So when you do the conversion here, you're getting rid of the pi by doing that. All right, and so that's the answer for that one. Okay, I think we're done with here. Now let's go on to the next thing that we're supposed to discuss. And I've been working on this for a couple days. We're going to need to review right triangle trigonometry and how it relates to the unit circle. This may be a heavy slog, so you definitely want to go slowly with this one. All right, let's get started. Okay, the first thing you have to remember is the SOHCAHTOA relationships, because that's going to be critical for what we're about to do. So remember, SOHCAHTOA is SOH for sine, CAH for cosine, TOA for tangent. Sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse, and tangent is opposite over adjacent. And notice, this is definitely significant, the fact that this hypotenuse is 1, and it would be here as well if we talk about the unit circle. So you have to remember that whatever we have, a squared plus b squared will be equal to 1 squared, or simply 1. This is super, super important for our understanding about what we're about to do. All right, so with that, let's go. All right, turning over. Okay, now the value of cosine of theta in this problem, you have to look for theta and find out what the adjacent is, and then what the hypotenuse is. The adjacent in this case is 5. The adjacent is 5, and the hypotenuse is 9.5. So we're going to literally divide 5 by 9.5. 5 divided by 9.5 gives us our ratio of 0.526, but you don't see that there because it's in decimal form. this calculator has the ability to convert that into a fraction. It just makes it a little bit easier. You go math, enter, enter, and it'll turn it into 10 over 19. So 10 over 19 is our correct answer for this one. And just to confirm, I'm going to pull out the tab here just to verify that. Okay, so we got that. But if you didn't have a calculator, it still wouldn't be a deal breaker because you could still do it by hand. 5 over 9.5 is the same thing as doing 50 over 95. And I would divide by 5. 5 into 50 is 10. And 5 into 95 is, in fact, 19. So we could have gotten it just by simple manipulation of of ratios, right? 5 divided by 5. Okay. Let's see what we have coming up next. Okay, now we have question 8. Doesn't matter. This is not really applicable to this exercise. The value of sine of A is the opposite of A divided by the hypotenuse of A. That would be 5 over 13. And that's easy. That's right here. And it left it in fractional form, so there was really nothing that complicated to do. The answer is D. All right, so I think we have that skill set built in now. So I'm going to now go on to our main. Oh, no, I have one more. My bad. Cosine of A is 4 over 5. Cosine of A is all right. This is where we have a slightly different situation here. We've got two sides that are actually given to us in this case, and we are going to need to use that to figure out what the angle is that created that ratio. So the cosine of A is 4 over 5. We're talking about this reference angle, and 4 is our adjacent, and by the way, this would have been 3, but it doesn't matter for us. What we need to do is figure out what to do with that information. And that means we're going to, oh, actually, no, we don't have to do inverse ratio at all. We just have to figure out what the tangent of A is. Okay, and okay, the easiest way to tell you to remember this is just to memorize it. This is really easy. 3, 4, 5 is a Pythagorean theorem triangle. It's called a Pythagorean triple, and it's the first of all of them. And there are theoretically an infinite amount of these, but this is the smallest one. You just have to figure out what this side would have been to be able to get the value of tangent of A, because tangent, remember, is the opposite over the adjacent, but you already have 4, so this would have been the opposite over 4. And if you do Pythagorean theorem, you would have known that A squared plus B squared equals C squared. You have 4 squared, that'll be 16, plus B squared is equal to 25. B squared is equal to 9, and as I said, B is equal to 3. But why go through all that when you just remember 3, 4, 5? And the tangent of A would be 3 over 4 because of that. And that's our correct answer for this set of problems. 3 over 4 is the correct answer. I hope that makes sense. I hope that makes sense. All right, lastly, we're going to use this concept to go into the next topic of, waiting for the page, drum roll maybe, special right triangles. They're called special for a specific reason, and I want to do a quick overview of what's going on here because it is going to be necessary for us to really integrate this into our knowledge base. All right, so the first one. A special right triangle is called that because it's got properties that help us do things much easier if we note them. All right, so there's 2 of them. They're both triangles, the blue. This is a 45, 45, 90 triangle. This is a 30, 60, 90 triangle. They're literally called that. And I'm going to break down each one of them to kind of explain why they're called special right triangles. It's going to require some prior knowledge from you. It's going to require you to refresh yourselves on a couple of concepts that you've encountered in the past, but which are coming up really important now. And the first one we already kind of handled already, and that was the idea of the Pythagorean theorem. You definitely need to do Pythagorean theorem and know that really well here. The other thing you're going to need to do is radicals. So we're going to have to use both of these concepts in this unit. So it helps if we do this quickly. The first thing I'm going to do is take a square. This is a square. And I'm going to do a square of dimension, I guess I'll do 1. 1's easiest. So I'm going to do 1, 1, 1, and 1. All right, and now if I wanted to figure out the length of this diagonal line, I would use the Pythagorean theorem. And the structure again is a squared plus b squared is equal to c squared. Now, this is 1, this is 1. It's basically, and that's, I'm doing the same values. This is a times a plus a plus a plus a. So I could do a squared plus a squared equals hypotenuse, right? So I could do a squared plus a squared is equal to c squared. But as you can see, this is a combined like term thing. So I could do 2a squared is equal to c squared. And then that means that a squared would be equal to c squared over 2. This is going to be useful in a second because now I am going to go back. I am going to erase these values. I'm going to get rid of the a and the a. I'm going to replace them with literal numbers here. I'm going to put a 1 and a 1 here. Now if I put that here, 1 squared plus 1 squared, or 2 times 1 squared, we could do it here. 1 squared plus 1 squared is equal to c squared. 1 plus 1 equals c squared. C squared is equal to 2. And that means that c would be equal to radical 2. Okay, c would be equal to radical 2. And what does that mean for us is the question. That means that I'm going to put radical 2 here. That's going to be useful for us because we can do a lot of things with that. Remember also that this is 90 degrees and 90 degrees. And so if I bisect that, I'm going to do 45 and 45. That's where the term 45, 45, 90 triangle comes from. And we know this is obviously going to be a right triangle. Now, if I have a 45, 45, 90 triangle, it helps to look at the proportions that I've got here. And one thing you can see, if I have 1 and I have a 1, I have a 1 here too. I have a 1, 1, 1 radical 2. So my proportions will be of 1, 1, 1 radical 2 when figuring out the hypotenuse side, the diagonal. If I had had 2 here and 2, then this would be a 2 radical 2. And that works every single time, regardless of the value that I've got on my side. So whatever comes up, it's going to be the same. All right, so if I did a 10 or 9 or 15, it doesn't make a difference. I would still have, say, 15, 15, and then 15 radical 2. The general form of that would be x, x, x radical 2. This helps a lot. Okay, because one thing that you'll be able to take away from that is if I change the page and I were to do a regular generic right triangle, I could come up with the length super fast by knowing that relationship. That's why it's useful to know that. So I'm going to draw a right triangle here, and I'm just going to declare that this is a 3, and this is a 3, and this is a 45, and this is a 45, 90 triangle. If I remember that I did what we did before, then I have 3, 3. This would be 3 radical 2. I don't have to go through the calculations anymore because it's going to be right. Okay, and I'm going to do a super quick proof of this. 3 squared. 3 squared is 9. So 9 plus 9 is equal to c squared. That makes c squared equal 18. Take the square root of that. That's going to give you c is equal to the square root of 18. Remember how we did it before? You take out the perfect square in here, which is 9, right? So this is the same thing as saying the square root of 9 times the square root of 2, which again will simplify to 3 radical 2. So this is correct. We already knew it though. We didn't have to do this. It was already there for us. And then the question becomes, what happens to our proportions as a result? What happens to our sign ratios, our trig ratios, if we know this to be true? So let's do about that. I'm going to back this up into the 1 proportions again. Let me change the color so I can recognize that. This will be, suppose I had a 1 here and a 1 here, then this would be a 1 radical 2 or just radical 2. Okay. Now we're going to set up our proportions based on any of these two angles. Remember, because this is isosceles, the angles are congruent, which means the sides are congruent, which is true because it's a from a square. Hypotenuse will be along the side. And remember, square root of 2 is kind of like equal to 1.414. This is useful to remember too, by the way. All right, these are all really useful things to keep in mind and remember as you're going through this. Now, set up our sine cosine tangent ratio. the sine of 45 degrees, and you can verify that with a calculator. The sine of 45 would be equal to the opposite, 1, over the hypotenuse radical 2. And it might take it this way, but you really aren't supposed to do it this way. What you're really supposed to do, you're never supposed to have a radical sign in the denominator, because what you're basically doing when you do that is dividing a number on top by an irrational value, which is kind of not possible technically. So what you would normally want to do is rationalize the denominator by multiplying the denominator by the value that's going to make it into an integer. In this case, it would be radical 2. If you multiply across, you'll see what happens. So if I do that, I'm going to get 1 times radical 2, which is radical 2. And radical 2 times radical 2 is radical 4, or 2. And now if I go to the calculator and I try to put that into the calculator to see what the values are going to be, I'm going to see that 1 divided by the square root of 2 will give me 0.707. Okay, I'm going to talk about that in a second. And if I also do the square root of 2 divided by 2, I'm also going to get, oh, that's not the right number, sorry. The square root, what do you call it, the parentheses, square root of 2 divided, no, it did it again. No, I'm not going to let you do that to me again. Divided by 2 is going to be 0.707. But if I multiply 0.007 by 2, I'm going to get 1.414, which is the hypotenuse length. So if you remember this proportion, that's going to help you a lot, because it's going to be really, really useful for us. Now, if we do the other one, the cosine of 45 is, again, a 1 over the radical 2. So the cosine of 45 and the sine of 45 degrees are both equal to each other. It's the same thing, radical 2 over 2. Or 1 over radical 2. But this is the more appropriate way. Lumen may take this, but I'm not sure. And the tangent of 45 degrees. The tangent of 45 is the opposite over the adjacent, or the sine over the cosine. But if you do the sine divided by the cosine, they're the same exact value. So the tangent of 45 will be 1. That makes life really easy. And again, that's an easy proof. Just make sure you're in degree mode when you do this. And we're going to go to the tangent of 45. That's equal to 1. So that's how we know we got it right. By the way, that's also a good way to know whether you're in radian mode or degree mode. Because if you did not have that in degree mode, if you were in radian mode, for example, like so now, and you did the same thing, the tangent of 45 would give you a completely different thing. It would not be the same thing. So be careful with that. If you don't get 1 when you do that test, you're not in degree mode. All right, so I hope that you can retain that. Now, that's going to be useful for us, not just yet, but it will come in handy later. All right, so now I'm going to do the same thing for the other shape, which, if you remember, was an equilateral triangle. I'm going to put an equilateral triangle into the picture. I just need to come up with it. And I guess I'll leave it, I don't know, orange, light orange. Okay, here it goes. I'm going to draw this, and I'm going to designate, I'm going to say, let me make that an equilateral triangle. An equilateral triangle, I can bisect that, but not corner to corner. I'm going to dissect it by going this way, bisect it, sorry, by going this way. Now, let's see what we have here. What do we know about the equilateral triangle? We know an equilateral triangle has equal sides, which is correct, and it's got equal sized angles. And if it's got an equal angle, that means it's 60 degrees and 60 degrees. And this normally would have been 60 degrees, but we bisected it, so it's 30 degrees. And 30 degrees here. So what we've done is created a 30, 60, 90 triangle, 2 of them actually back to back. Now, in terms of what happens with our length, I'm going to say that this is a 2, and that would make this a 2. But again, because we're bisecting the lengths, that means that this is no longer 2. This is a 1 and a 1. Now, we would still have to figure out what that height is, because that's an important shape for us. We really want to know what that shape is so that we can use it. So I'm going to draw this random triangle here, and I'm going to set it up. I know that this is 2. I know that this is 1. So what's that? And I know that I can use my Pythagorean theorem because it's a right triangle, I have everything I need here. I'm just putting it in. I don't need this here just yet, but I can do Pythagorean theorem. I'm going to give this like I guess a letter x. I guess x squared plus 1 squared. 1 squared is 1 is equal to 2 squared, right? Which is 4. All right, continue that down. X squared plus 1 equals 4. Therefore, x is equal to 3. X squared is equal to 3. And that means that x is equal to the square root of 3. And the square root of 3 is almost as important. It's just as important as square root of 2. Square root of 2 is 1.414. I really think you would be well served to remember this number. Square root of 3 is also a valuable number to remember. It's 1.731 roughly. It's irrational, never ends, no pattern. But if you remember that, you should be okay. And that also means that our proportions would be the same for this triangle as well. So if this is 1 and this is 2, this would be 1 radical 3. Now, I'm going to go through this in detail. I'm going to use this shape here. I'm going to go to a different page. And this one is really, really cool, and it makes life really, really easy when you keep that property in mind, because it makes solving the trig ratio super simple. All right, so let's see what we do. Suppose I change the side length. Now remember that it came from an equilateral triangle, right? So 60 degrees would be here. And also remember that it would have had a counterpart over here that we do not see because we don't care about it right now. So given any length, for example, if I had 8, this would have been a bisected 8, or 4. Okay, and if I do, I'm going to do this one super quick. X squared plus 4 squared, which is 16, is equal to 64. X squared would be 48, and x would be the square root of 48. The square root of 48 is, again, taking the biggest square root I can find out of that. Pick a perfect square would be 16. The square root of 16 times the square root of 3, because 16 times 3 is 48, and this reduces down to 4 radical 3. So kind of similar to the square-based one, the 45, 45, 90 triangle, we have a proportion again. And if we have this as a side, and this is a hypotenuse, this will be twice the side. So I'm really going to refer to this going forward as a critical angle. All right, I'll go into more detail in a second about what that means, but I can always take it to the bank. If this is 4, this is twice of 4. And if this is 4, this will be the 4 with a radical 3 attached to it. And that proportion will hold every single time. It never fails to work. So that's why we use it, and that's why we even look at it. We're going to do another one with a different proportion. And if we were in class, I would ask you to give me a proportion, but since we're not together, I'll just come up with a number. I'll do 5 here. If this is 5, this will be 10. This will be 10. Let me try again. It disappeared on me. This will be a 10. Guaranteed. It's a 10. And if this is a 5 and this is a 10, that had to be 60 degrees. No question about it. I don't like the way that looks. I'm going to fix that. That would be a 60 degrees. And the 60 degree proportion is always 1 to 2, given that this is a 90 degree triangle. And if this is 5, I guarantee it. This will be 5 radical 3. I guarantee it. It works out every single time. Quick check. A squared plus b squared equals c squared, right? All right, so if I didn't know what this was, if I put x here, x squared plus 25 equals 100, x squared is equal to 75, x is equal to root 75, which is root of 25 and root of 3, or 5 radical 3. So again, I don't have to do any of this anymore because I know the proportion is going to be like this. So if I have side, I have 2 times the side, and then the middle length is the side times radical 3. That proportion will always hold as well. All right, and that's going to be useful as well. Let's just do 2 more practice questions like this just to get this really, really locked away. I'm just going to draw a what I would try to make a 45, 45, 90 triangle. It's not quite there, but we'll take it as it is, 45 degrees and 45 degrees. And think of any number you want. Think of 7. If this is 7, this will be 7. This will be 7 radical 2. And the way to really keep this in mind is that the dominant theme for this triangle is 2. 2 of these angles are the same. 2 of these sides are the same. So radical 2, that's our dominant theme for this triangle, all right? And that's always going to happen. And to contrast and compare it to the other one that we just did a second ago, all right, we have proportions, but they're different. And remember that the proportions are based on a different number, not radical 2 or 2. 2 is not the dominant theme here. This is 30, this is 60, and this is 90. And the thing they all have in common is the number 3. The value of 3 is common to everybody, right? So we're going to keep that in mind. So if I come up with a number, say the same number, 7, 14, because twice 60, right? And 30. I miswrote that, didn't see that. So this is 60. This is my critical angle, 7 to 14, or 14 down to 7. Doesn't make a difference. So this is 7 radical 3. So the dominant theme for this triangle is 3's. The dominant theme for this triangle is 2. And that becomes really easy to remember as a result of that. So that's by way of explaining what this initial picture was trying to explain to us. But it's a little bit complicated in the beginning unless you keep those little mental mnemonics in mind. Okay, so let me go back to that image that we had before. Nope, not here. It looks like it's going to be here. Nope, not here either. One more time. I think this will do it. Yeah. Okay. So this is explaining everything we just did. All right. If this went too far. If that's on the triangle, the square contains two triangles that are isosceles, right triangles. This is going to be a proportion of x radical 2. All right. And this is just going up from smallest to largest. X radical 3, 2x. But remember, 60 is the critical angle, which means that if it's 90 degrees and this is 60 here, then I know that whatever the longest side is, the hypotenuse, this was half of that. All right, so if this is 2, this would be 1. If this is 6, this would be 3. If it's 6 and 3, this is 3 radical 3. If it's 14 and 7, this is 7 radical 3. All right, if it's 20 and 10, this is 10 radical 3. So that's what this is doing. And we need to know that really, really cold so that we can proceed with going into the explanation of the unit circle. So I'm going to turn the page into the next section. And it's just really slow turning the page on this thing. Waiting for it, waiting for it, waiting for it. Okay, waiting for it again. I actually am hitting the pages. Okay, so now we'll look at this one. It's going to jump past, I think. I can't tell. Nope, there it is. Okay, it's going to jump past. I'm going to go back to that question. And I think I hit the left bound key too fast. So this is the question that I was trying to get back to. If I know what this is, this, according to the designate, this is the indicator. This tells me that this is a certain angle, and this is the exact same angle because the marks are identical, which would make this a 45, 45, 90 triangle. Now they want us to find x and or y, but we know that because it's isosceles, this will have to be a 5. Guaranteed it's going to be 5. And that answer's here, but it's not what they want. They want the hypotenuse. And remember, you just add a radical 2 to the back of that, and you're going to get 5 radical 2. That's the answer to this problem. And I hope this makes sense to you, because it's really easy once you get the hang of it. It does take a little practice, though, sometimes. I'm going to go to number 11. They want the sine value of the 45-degree angles of the triangle. All right, the sine value. All right, so in order to get the sine, we need to get the opposite over the hypotenuse. All right, and since we're talking about this angle, this side here, it's opposite from that angle. And it doesn't make a difference because this would be the same thing here. 9 radical 2 over 2 would be the same here. The question is, what's the sine value? And in order to do that, we're going to have to figure out what x is in this case. And so we could do 9 radical 2 over 2 squared plus 9 radical 2 over 2 squared equaling x squared. We could do that. We could do that. Or we could just take the idea that we know that 9 radical 2 over 2 would have a radical 2 behind it. Because whatever it is, radical 2, right? 5 radical 2. 6 radical 2. This would be 9 times radical 2 times radical 2. Radical 2 times radical 2 is 2. So it'd be 9 times 2 divided by 2. And the 2's cancel, so you're going to get 9. All right, so the sine of 45 would need that 9 to go here. All right, so that's what's going to happen here. I know this format is really unfortunate, but it's not that bad at the same time. And had I done this, I would have gotten 81 times 2 divided by 4 plus 81 times 2 divided by 4, and that's going to give me what, 81 over 2 plus 81 over 2. That's half of 81. Half of 81 plus half of 81 is 81. Okay, and then if I take the square root of that, I'm going to get 9. Right? The square root of 81 is 9. So it just verifies that we got our values correct. But again, not really hard. You could do it either one of the two ways. And again, this is the important proportion, x, x, x radical 2, regardless of what this is. This is always going to be the same. Now, because I know that we did the proportion, the sine of 45, if I do it in a calculator, let me go back to that. The sine of 45 should be 0.707, which if you remembered from before, it's the same thing as doing the square root of 2, which is 1.414, roughly equal to 1.414, divided by 2, which will give you the 0.707. So the calculator, if you remember that 0.707 is half of radical 2, that's also going to help you too. That's a huge, huge help for you too. All right, so I hope this is making sense so far. I'm going to go on to the next page. And where are we? Okay, the value of the cosine of 30. The value of the cosine of 30. Cosine 30, okay, we need this, and we have the adjacent. Remember, cosine is adjacent over hypotenuse, but I do need the hypotenuse, okay? And this is a critical angle. Remember, I told you it's a critical angle. And that means that because of the critical angle being here, this is twice of whatever x is. So I know to look for that. And I also know that I can take 7 radical 3. Remember the structure, side, 2 times the side, and then side radical 3. That means the side here is 7. And if the side radical 3 is 7, that means that this is 7 and this is 14. All right, so now the cosine of 30. The cosine of 30 is 7 radical 3 divided by 14. Which is radical 3 over 2. And if I do square root of 3 over 2, the square root of, shoot, not this one. Let me go back. Let me quit out of here. I missed the square root of 3. No, I don't like that. No, okay. Well, let me see. I don't know if it'll work or not. This calculator's a little temperamental. I don't like that. Okay. Maybe now. Divided by 2 will give me 0.8666. Okay, so that's another thing you could remember that would be really useful for you. 0.707 being the sine of 45 is radical 2 divided by 2. The square root of 3 divided by 2, cosine of 30, that would be 0.866. But if I look at 0.866, it's the same thing as radical 3 over 2. Okay, and I'm telling you, it's really going to be useful if you remember that too. Super, super easy to remember, but you got to put the effort into that. Oh, by the way, that means that our answer is D. The cosine of 30 is equal to radical 3 over 2. Regardless of what the lengths are, or regardless of what you calculate, those proportions will always hold standard. It's always going to be consistent. All right, so where are we now? We're coming up on 33 minutes now. No, 34 minutes now. Okay, the hypotenuse of a 30-60-90 triangle. The hypotenuse of a 30-60-90 triangle is 13 centimeters. Okay, and what does it want? What is the length of the shorter leg? All right, so if I know that the hypotenuse is 13, if the hypotenuse is 13, and this is 60, and this is 30, half of 13 would be 6.5, right? And if I have this, I have this. I just put 6.5 here and put a radical 3 behind it, okay? But the shorter leg, this is the longest side, but of the two here, this is the longer leg, and this is the shorter leg. So the answer should be A. If I'm reading that question correctly, the answer should be A, and it is. If it said something like the middle leg or the longer leg, then you would put 6.5 radical 3. All right, so let me bring the question up to view so you can see it. All right, and then what are we here? Okay, the length of the longer leg is 12. All right, well, we're going to have to play with this one for a second because this one's going to make us a little bit dizzy. The longer leg of this triangle is going to be 12. This is 12. All right, and this is 60, and this is 30. All right, but remember what we said here. We said this is a side, this is 2 times the side, but this is the side times radical 3 for 12. Okay, that means that the radical 3 was bundled in. You can't see it, but it does exist. So if we solve this, side times radical 3 equals 12, we're going to solve for s. That's going to be 12 over radical 3. And that might take it, but notice it's not here because it's not the proper form. So we're going to rationalize the denominator. Because this is radical 3, we're going to multiply it by radical 3. And that'll get rid of the radical 3 and turn it into a full 3. And if I do that first, it'll make sense. Radical 3 times radical 3 is 3. 12 times radical 3 would be in the numerator. And now you'll see that 12 divided by 3 reduces down to 4 radical 3. So our answer is 4 radical 3. And that would be S. S is 4 radical 3. You can test that by multiplying 4 radical 3 with radical 3, which will give you 4 times 3 and 12. And if that's correct, the hypotenuse would be double this. That would be 4 times 2, or 8 radical 3. So our answer is 8 radical 3, or in this case, option A. Okay, this is easy, but it does require practice. All right, so let me see where we are at the moment. Okay, now this is going to take us to the initial side, terminal side discussion. I'm going to save this for the next video, but it's a good place to stop for a second.